Okay. Hello, everybody. A very good evening. I hope you're doing great. So, have I made host? Yeah, I am the co-host. So I'll be able to share the screen. Right? Fine. Just a moment. I'll just bring some questions. Last class we actually saw about this enthalpy, so we have to solve some questions. So we'll just quickly do that. Just give me one moment. All right, all set to go. Let me share my screen. Okay, people. Hope you remember what and all we saw last class, right? I said it was only yesterday. Hope you remember all those stuff, right? So where is it? Let's just give you a quick recap of whatever we have been seeing. Now we'll come back to the entropy later, as I said, right? So we start with thermochemistry, right? So as I said, we are going to deal with different types of chemical reactions and their energy along with the chemical reaction happening, right? So we saw first what was enthalpy of formation, right? And we have something called the standard values, non-standard values. So it's all about the temperature and pressure. At what temperature and what pressure you are measuring that's the one which is going to make a difference, right? So we know how to define the enthalpy of formation. It is enthalpy occurring when 1 mole of that particular compound is formed from its constituent elements in their standard states, right? Hope you all remember that. So if at all we give an enthalpy of formation of H2O, this is how we write the equation. This is just a chemical equation. Now if you include the enthalpy value, that is going to become your thermochemical equation, right? And then we have to remember one important point, that enthalpies of formation of the elements in their standard states are zero, right? For example, for H2, for Zn, for zinc, for anything which you see in standard state, that particular element, that particular enthalpy value is zero. Enthalpy of formation value is zero, right? Then we saw what is enthalpy of combustion, right? I don't know where we written it. Okay, oh, this is again enthalpy of formation only, right? And these are some properties which you have to remember. Whenever we reverse the reaction, we change the sign. Whenever we multiply a reaction by a factor, we do the same thing with their enthalpy values. And whenever you add or subtract two reactions, you again add the corresponding enthalpy values, right? Okay. Then we saw about enthalpy of combustion. It's all about that 1 mole of compound undergoing combustion, that is reacting with required amount of oxygen to form the corresponding products. And what is enthalpy change occurring? That is what is your enthalpy value, right? And then we saw about bond enthalpies, and that bond enthalpy can also be called as enthalpy of atomization. So from the name itself, you can understand I'm going to convert 1 mole of molecules or 1 mole of compound into their corresponding atoms. Be very careful. People confuse that, okay, enthalpy of atomization and enthalpy of formation are just opposite, but they are not. In enthalpy of formation, we take the elements in their standard states. Here, the elements are going to be in their atomic states. Be very careful, right? So whatever be the molecule, just convert them into the corresponding atom. Whatever be the compound, just convert them into atoms. And then we saw about this enthalpy, bond dissociation enthalpy. Now here we are going to take one specific bond in a molecule and how much energy is required to break that particular bond. That is what is called as a bond dissociation enthalpy. So we will be able to connect your bond enthalpy with your bond dissociation enthalpies, right? So all that you have to do is just see what types of bonds are there and how many types of such bonds are there, and individually break it, right? So C2H5OH, we understand that there are going to be this many bonds. That is 1 CC bond, 5 CH bonds, 1 CO bond, and 1 OH bond. All of them has to be broken, right? And then we'll be able to connect your bond enthalpy with your bond dissociation enthalpies, right? And then we saw for enthalpy of overall reaction, yes, right? And then we know we'll be able to talk about this enthalpy of overall reaction with respect to enthalpy of formation, with respect to your enthalpy of combustion, and obviously with respect to your bond enthalpies. With respect to enthalpy of formation, it is going to be total enthalpy of products, that is total enthalpy of formation of products minus total enthalpy of formation of reactants. And in both in the case of enthalpy of combustion and in the case of bond enthalpy, why are you not coming? Yeah, it is going to be total enthalpy with respect to reactant minus the product, right? And that is where we stopped last class. All right. So now we will do good number of problems. I think the entire class will go on problems only. So please get your notebook, get your pen, and start solving. Okay. Anyways, I'm going to be first 1 or 2 problems. I will help you. And from then on, you'll be able to work it out yourself. All right. Okay, people. Okay. Okay. Before we move on, I just wanted to tell something about this physical processes. Okay, people. See, we can have the first one is what is enthalpy of vaporization, right? See, these are not chemical processes. I know vaporization is nothing but boiling, right? Right. So, like, it is very easy to understand that if I like again, this is the definition is going to be very very simple, right? I will be able to represent this one as enthalpy of vaporization delta H VAP, right? Now, whenever I talk about enthalpy of vaporization, I'm talking about that particular compound or that particular chemical species in liquid state going to your vapor state, right? So please take down the definitions also, right? So it is going to be helpful for us. It is the enthalpy change occurring. It is the enthalpy change occurring when 1 mole of a chemical species, when 1 mole of a chemical species in liquid state, in liquid state, 1 mole of a chemical species in liquid state gets converted into their vapor state or gaseous state, however you want to call it, right? So I'll repeat the entire statement one more time. It is the enthalpy change occurring when 1 mole of a chemical species in liquid state gets converted into their gaseous state or vapor state, right? Say for example, if I tell enthalpy of vaporization of H2O is some X, right? Now, how do you write the equation? You have to make sure that only 1 mole of the particular chemical species is there. So H2O liquid to H2O gas, whatever is the enthalpy change occurring, that value is what is enthalpy of vaporization. So for this particular, not reaction, but for this particular process, the enthalpy change is nothing but X kilojoules per mole. Right now, same way, I will be able to have it for enthalpy of fusion. Right? What is fusion? Fusion is nothing but melting. Right? So again, I'll be able to talk with respect in the same way. I think you'll be able to correlate between enthalpy of vaporization and enthalpy of fusion. Here in this case, we have to go for solid state to liquid state. Fusion is melting, right? And same way, we can have enthalpy, and it is represented by delta HFUS. Okay, it is represented by delta HFUS. And then at last, we can have enthalpy of sublimation. I think from the name itself, you'll be able to get what I'm trying to say, right? You know, sublimation is where I have solids getting converted into the gaseous state directly. Camphor, dry ice, all these are different examples. So I will be able to represent this as delta H sub SUB. Okay, it is very simple. You have to convert that particular state into the other state. That's it. That enthalpy is occurring in that particular process is what is called as your enthalpy of that particular physical change. This is not a chemical process, but a physical process, right? So these things also you can know because it can be correlated. Okay. Okay, take down. Calculate the enthalpy of combustion. Calculate the enthalpy of combustion of ethene gas. Ethene. Calculate the enthalpy of combustion of ethene gas. Right? What do you have to find? Enthalpy of combustion of C2H4. That's what you need to find. Okay. Right. So calculate the enthalpy of combustion of ethene gas. Given that delta HF, that is enthalpy of formations of CO2 is minus 394 kilojoules per mole, and enthalpy of formation of H2O is how much? Minus 242 kilojoule per mole, and enthalpy of formation of C2H4 is minus 52 kilojoules per mole. Okay, right? So this is the question to you, right? So you try it out for 2 minutes from whatever the knowledge which you have seen, right? You don't have to get the answer, but at least think about it, how you're going to do the problem. If you come up with a process, right, let me know. I'll give you 2 minutes time to think about it. You have to find the enthalpy of combustion of C2H4 and all the enthalpies of formation of 3 species, that is CO2, H2O, and C2H4 are given to you, right? Think about it. Okay. Anybody got any idea of how to do the problem? Okay, right, people. See, now let us write the, like, whenever the equation is given to, whenever enthalpy of particle enthalpy is given to you, you know how to write the chemical equation, thermochemical equation for that, isn't it? Right. So let us write the enthalpy of combustion of C2H4 is thermochemical equation. Let us write. Okay. Fine. How will you write it? Enthalpy of combustion is where that particular reactant, that particular compound is going to combine with oxygen, required amount of oxygen, to form the products. Right. So let us do the reaction now. So the required equation, what we have in hand is C2H4 undergoing combustion. That is, it is going to react with O2 to form obviously any hydrocarbon on combustion will always form carbon dioxide and water. Yes, but we need to balance it. So we have 2 CO2 because I need to have 2 carbon atoms and I have 4 hydrogen atoms. So this is going to be 2, so that 4 hydrogen atoms. How many total oxygen atom? 2 into 2, 4, 4 plus 2, 6, right? So we need to put 3 O2 here, right? Now, people, for this reaction, can I write enthalpy of reaction is what we have to find? Basically, they have asked you to find the enthalpy of combustion. Enthalpy of combustion means this is the reaction which you have to find. The enthalpy value for this reaction is what we have to find. So basically for this reaction, I have to find your enthalpy of the overall reaction. Is it not? Right? And we know how to calculate the enthalpy of overall reaction from your enthalpies of formation. Right? How do you calculate it? Enthalpies of reaction, overall reaction is equal to total enthalpy of formation of products minus total enthalpy of formation of reactants. Yes. Now all those things are given to you people. Is it not? Go for it. Enthalpy of reaction, or that in this case it is nothing but the enthalpy of combustion of C2H4 is nothing but, now we'll write first the products, 2 into enthalpy of formation of CO2 because I have a stoichiometric coefficient of 2 minus 2 into enthalpy of formation of H2O, and that is about it. I'm sorry, not minus, plus. Right? Now this is one term, that is your product part, minus the reactant part. Minus the reactant part, that is enthalpies of formation of C2H4 minus enthalpy of formation of O2. I would say 3 into enthalpy of formation of O2. Right? And that these are your reactants. This is how we write it. Is it not? Now people, can you substitute the values here? Right? So enthalpy of formation of CO2 is minus 394. So we should write 2 into minus 394 plus enthalpy of formation of H2O is minus 242. So it is going to be 2 into minus 242. Right? Okay, this is one term. Whole thing negative minus of enthalpy of formation of C2H4, that is minus 52 kilojoules. Okay, minus 52. Okay, 1 into minus 52. Right? Okay, and then plus enthalpy of formation of O2. What is the value of enthalpy formation of O2, people? What is the value of enthalpy of formation of O2?
0, sir.
0, right? Because oxygen is in the standard state. This is your free state or standard state of oxygen. And whenever some element is in standard state, that value is going to be 0. The enthalpy of formation value is going to be 0. That's it. You know everything. You just have to calculate and find the answer. Right? This is how questions will be asked. This is one type of question. Right? So in this kind of question, what they're asking is, they have given you a reaction. They have, like say, indirectly given you a reaction and asking you to find the enthalpy of overall reaction using your enthalpies of formation. All right. Okay, fine. Moving on to the next question. Okay. There's so much background noise. I'm so sorry. Okay. So I can take okay. Second question. Right. So you have to calculate enthalpy of formation of acetylene. You have to find. Okay. First, what is acetylene, people? Do you know what is acetylene? Oxyacetylene flame. Have you ever heard of it? It is used in welding. Oxyacetylene flame. Have you heard of it? Okay, fine. If you don't know, now know it. Acetylene is nothing but ethine. Okay, the common name of ethine is what is called as acetylene. Okay, we know the formula. Formula is nothing but CH triple bond CH. Right? Okay. So, what they have given is, right? Now, see, the question given here is in different form, but I'm going to little modify the question and ask you this. Okay, because that is going to take up a lot of other things also, right? So you have to find the enthalpy of formation of ethyne acetylene. Okay. Now what and all is given to you is enthalpy of formation of carbon dioxide, right? Enthalpy of formation of carbon dioxide is given to you as minus 393.5 kilojoules per mole, and they have given enthalpy of formation of water H2O to be how much? Minus 285.8 kilojoules per mole, and they have given enthalpy of combustion of C2H2, that is nothing but CH triple bond CH. Okay, the enthalpy of combustion of C2H2. No, I'm going to give it the other way. Okay, take this, no issues. Right. So enthalpy of combustion of C2H2 is given as 1, 2, is approximately 2,600, right? 2,600 means 1,300. Okay, minus 1,300 kilojoules per mole. Okay, right? So again, think about it. How do you going to do this? And I'm going to help you. So here we have to know how do you write the reactions, right? And we have to know what are the properties of enthalpies, right? So I told you that you will be able to reverse the reaction, you will be able to multiply throughout the reaction, you will be able to add 2 or more reactions, right? So think about it, right? There is one required equation. The required equation is for that of enthalpy of formation of C2H2, right? And they have given you 3 other enthalpies. For that also you'll be able to get some equations, right? So you have to do something to the equations so that you will be able to get the required equation. I almost told the answer. Okay.
Sir, can I try?
Yeah, go on.
Sir, enthalpy of combustion of C2H2 plus O2 gives enthalpy of we have to use the enthalpy of combustion reaction. So first, for that, delta H of the whole reaction equals to 1 second, sir. I have to balance the equation.
There are multiple ways of doing a problem, obviously. Yeah, I get what you're trying to say. Yes. Okay, so I get what you're trying to say. Okay, that makes sense. Yes, that's one way of doing the problem. Let me explain what Suprajit is trying to say, everyone. Right. So people, for this particular reaction, right? Let us write the equation first. Okay, first, fine. You have to find what enthalpy of formation of C2H2 is what we have to find. Right. Okay. Now there are 2 ways of doing the problem. Both the ways I'll tell you. First, let us do the Suprajit way. Right. Okay. So how to write the reaction? We already know, right? C2H2 is going to combine with oxygen to form carbon dioxide and water. Okay, right? So we have 2 carbons and 2 hydrogens only, no issues. Now directly we can go for this. How many oxygens are there? Totally 4 plus 1, 5. So here I have to put 5 by 2 O2. That's it. This is the balanced equation, right? So now we know the enthalpy value for this delta HR, or say the enthalpy of this reaction is given to us. How much? Minus 1,300 kilojoules per mole is given to us. Again, we'll be able to write in terms of enthalpies of formation, right? How do we write delta HR, or which in this case, delta HR, which is nothing but delta HC of C2H2 is nothing but, first we'll talk about the product, 2 into enthalpies of formation of CO2. Wait. Right? So 2 into enthalpies of formation of CO2 plus enthalpy of formation of 1 into enthalpy of formation of H2O. All right. Minus enthalpy of formation of C2H2 and O2. I don't have to write because that value is going to become 0. Enthalpy of formation of elements in their standard state is 0. I do not have to write that. Right? Now we know this value now. Delta HR we already know, or delta HC we already know, that is minus 1,300 kilojoules per mole. Right? Now, okay, let me write it down. Right? Okay. So we have minus 1,300 kilojoules per mole is equal to 2 into enthalpy of formation of CO2. Enthalpy of formation of CO2 is given to us minus 393.5 up. Yeah, minus 393.5 kilojoules per mole plus enthalpy of formation of water. Enthalpy of formation of water is minus 285 minus 285. Oh God. Right, so it is minus 285.5 kilojoules per mole, minus of enthalpy of formation of C2H2. This value is what we need to find, right? And all the other values are known to us. This value is known, this value is known. So you just have to find this value from this equation. This is one way. Okay, right? This is what you're trying to say, isn't it, Subrajit?
Yes, sir. Exactly, sir.
Right, good. So this is one of the way of doing it. Right, now there is another way of doing it. I would say this is a better method. Okay, this is a better method, better way of doing it, but there's a little more lengthy way of doing it. Okay, so whichever strikes your mind at that time, you'll be able to do that. Okay, now why I want to teach you that method is because again, this problem you are able to solve this in the method, but certain problems you will not be able to solve this method, and whatever method I am going to teach you, that method is the only method available for us to solve. Okay, I'm going to teach you that now. Right. So now look at this thing. Right. So let us write the reaction for this. Right. So we have to form C2H2. Okay. Form C2H2, and we understand that we need to form it from the corresponding elements in their standard states. Right. So we need to have carbon. Right. We need to have carbon plus carbon graphite. Okay. Right. Carbon in the form of graphite plus plus hydrogen is going to give you C2H2. Let me write this properly. Is going to give you C2H2. All right. Now you have to balance it. So 2 and then 1. Yeah. So this is what this enthalpy is what we need to find. Okay. For the reaction, for this particular reaction, the enthalpy value is what we need to find. All right. Okay. Now this is your required equation. Okay, this is your required equation. We have to somehow get this equation from these thermochemical equations. Okay, something we have to do so that we'll be able to get that particular equation. Okay, right. So now let us write the equation for this. Enthalpy of formation of CO2. Okay, so we have carbon in the form of graphite reacting with O2 to form CO2, and that enthalpy value is what is given as minus 393.5. Okay, right. Now let us write this reaction also. Formation of H2O, H2 plus half O2 giving H2O. Again, you have to make sure that only 1 mole of product is formed. That's why I'm making half O2. Okay, and the enthalpy value is given to us as minus 285.5. Okay, and we'll be able to write this equation also. C2H2 plus O2 giving CO2 plus H2O. So we need to have 5 by 2 O2 to this thing, and then yeah, done. That's your balanced equation. And for this also, enthalpy value is given to us. Enthalpy value is minus 1,300 kilojoules per mole. Okay. Now, see people, you have to do something to these equations so that you will be able to get this equation. And whatever you do to the equations, the same thing has to be done for their enthalpy values. So, right? Okay. Now let us look into it. So we require, let us go by product and reactant side. Okay. Now we understand that we need carbon graphite. We need carbon graphite in the reactant side. Okay. And that is not the only thing. We require 2 carbon graphite in the reactant side. Okay. Now first let us check where is carbon graphite. Carbon graphite is here. That is in the CO2 equation. Right. Okay. It is there in the reactant side. Okay. But what we need to have is 2 carbon graphites. Right. So what I can do is I can multiply this entire equation by 2. Okay, I can multiply this entire equation by 2. So what will we get? We will be getting 2 carbon graphite. Forget about other things. Don't worry about other things. Delta H value will change. So let me write it as delta H1. So if you multiply by this by 2, we'll be getting delta H1 into 2. Whatever be the value, we multiply by 2. That we know. Okay, right. Next one, what we need to have? We require H2 also on the reactant side. Is it not? We require H2 also on the reactant side. Okay, H2 is there in the reactant side and I require 1 mole of H2. So 1 mole of H2, let us keep it as such. This is exactly what we require. Forget about the other things. All right. Okay. Then what we require? We require C2H2 on the product side. We require C2H2 on the product side. See where is C2H2? C2H2 is available here. Right, but where I have it in the reactant side. So obviously what I have to do, I have to reverse this equation. So then what happens when you reverse it? C2H2 will go into the reactant product side and the delta H, say, let me call it as delta H2, let me call it as delta H3. Now delta H3 value will become what? It will become plus 1300. Whenever you reverse the reaction, change the sign of the enthalpy. That's it. Now you have all the things wherever you need, how much ever you need at the appropriate places. Right now, what you have to do, say this is equation number 1, this is equation number 2, this is equation number 3. Just add 1, 2, and 3. You are going to get your enthalpy. I mean, you're going to get the required equation. This is your required equation, right? And you will be able to get your enthalpy values also sorted. That is, say, or let me write it this properly. So if this was equation number 1, what we did to equation number 1? Right, we multiplied equation number 1 into 2. Right, so we will write delta H1 into 2. Right, that plus what we did, we just added the second equation. That's it. We didn't do anything to the second equation. Third equation we reversed it. So we write minus 3 and we didn't multiply anything. So keep it as such. So plus 2 into delta H1 plus delta H2 minus delta H3 is what is your enthalpy of formation of C2H2. As simple as that. You do not have to worry about what is happening with the other things. See what I want, where I want, how much I want, and do those things to the given equations and do the additions. You will be able to get the required equations and you will be able to get the enthalpy values also sorted. Okay. So 2 methods. Obviously, the first method was a little more, little shorter way, right? But this also sometimes will help you. Like maybe in this reaction, it is not going to be helping you. But in some other reaction, this might be the only way out, and you have to do this. Anybody has any questions, please ask me if you have any questions. Obviously, I understand that first time itself, you are not, we are not Einstein, right? Yeah, including me. I am not Einstein. First time, it might be difficult, and I am not, I don't know, like, right? So whomever be the faculty who is teaching you, right? You might or might not get it the first time, right? So if you don't understand, if you ask me, want me to explain again, I will explain again. Anybody requires it again. Everybody understood?
Yes.
Right? Okay, good. If you do not understand, please ask me. Please do ask me. Okay. So another question will solve. Right? Another question will solve. Okay, people. Okay. No, the book which I wanted, I left it in Bangalore. This book, I'm just, I don't find it that interesting problems. Okay, I think this you have to solve it by this method only. Fine. So they're asking, find delta HR for hydrogenation of ethyne. Or they have given us the question as hydrogenation of acetylene. Okay, we know acetylene is nothing but ethyne, right? Okay, so you have to find the enthalpy of reaction of this reaction, hydrogenation of ethyne. Okay, and what and all are given to you is enthalpy of formation of water. Okay, now here it is given in terms of calories. Don't worry about it. So it is 68.3 kilocalories per mole. Heat of what is this? Heat of combustion. Heat of combustion of C2H2 is given as minus 310 kilocalories per mole, and then heat of this. Okay, right, and then they have given heat of combustion of ethylene. Ethylene is C2H4, right, and that is given as minus 337.2 kilocalories per mole. See, when I say hydrogenation, I'm talking about like, see, in this question, even if like you have to understand that we are going for converting your C2H2. Obviously, I'm going to add H2 to this, and we are going to form ethene, not ethane. Okay, what I'm trying to say is we have CH triple bond CH reacting with H2 to form CH2 double bond CH2, not CH2, I mean not CH3, CH3. Now, how do you understand this? Because look at the values given to you. It is given only for C2H4 and C2H2. The C2H6, that is CH3, is not given. Okay, so you have to understand that this is partial hydrogenation only. That means we are going to convert ethyne to ethene. That's what you're going to do. That's what you're doing here. Okay, so basically you have to find the enthalpy of reaction for this. You have to find the enthalpy for this particular reaction given these are the data. Okay, so I suppose I don't think you will be able to do it by the first method we saw it in the previous question, right? You have to use the method which I taught you. Okay, or if at all you're able to solve by the first method, go on. Please tell me that I'll also learn how to do that, right? But I don't think so you'll be able to do. But try it out. Like you try the second method, write the equations, do something to the equation, and this is your required equation now. Required equation is what is required equation. Do something to the given equation so that you will be able to get the required equation. And obviously, whatever you do to the given equations, the same thing has to be correlated to your enthalpy values also. Right? Go for it. I wrote KCl, this is kilocalories.
Sir.
Yes.
Sir, in the question, they should give the heat of formation of CO2, right?
Heat of formation of CO2, not required. It is going to get cancelled, right? Like if you're doing by the
Sir,
first
understood,
method,
sir.
right? I think that's what you'll not be able to do. But if you do by the reaction method, doing something to the reaction, eventually it'll cancel out. Don't worry about it. people, after this chapter, I'll be starting with equilibrium. And after that, we have two more chapters, that is S block elements and P block elements. So this is February. So in February itself, I'll be completing equilibrium and I'll be starting with S block elements. I think I should be completing in the March first week, second week. It should be done. Please do not sit idle. Take your notebooks, take your pens, and start solving. If you do not solve it here, I'm giving you time to solve. I don't know what happens in your school. Like, I don't know whether they give you time to solve, right? Please utilize this time. Now that you have already learned it, most of the students, for them already thermodynamics is over in your school, right? This is the right time to practice, right? Go for it. You can use your calculators for this class, but obviously you will not be able to use them in your exams. Right? Just so that you'll be able to solve more number of questions, I am allowing you to use your calculators. And guys, you wrote your exams, right? Or gaseous states of matter. How was the exam? Was it okay? Was it easy, tough?
Easy only, sir.
Easy only, right? But I don't know. I saw the question paper. There was no question from Graham's law. There was no question from that velocities, right? I don't know. Anyways, maybe in your exams you will get, okay, right? In your school exams you will get those questions also. So practice them. Just practice your book back exercises. That is your NCRT book back exercises. That should be more than sufficient. So we're still doing. Okay. Can I do?
Sir, can you just give 2 minutes?
Okay.
Sir, you can do, sir.
Okay. Fine. So now this is the required equation, right? From the height, they are asking you enthalpy of reaction of hydrogenation of ethene, that is this reaction. And for this, you have to find the enthalpy value. Okay, right. So let us write the equations corresponding to each and everything given to us. So this, I'll be able to write it as H2 plus half O2 giving H2O. And for this enthalpy is what is given as minus 68.0. Let's write this properly. Minus 68.3 kilojoule, kilocalories, whatever it is. Okay. Next, enthalpy of combustion of C2H2 is given. So we write C2H2 plus O2 giving CO2 plus H2O, 2 carbons and 2 hydrogens. This should be 4 plus 1, 5 by 2 O2. And for this, the enthalpy is given as 310, right? 310.6. Let me write it as delta H1, delta H2. Okay. Delta H2 is minus 310.6. Okay. 310.6. Okay. Next, what is given? Enthalpy of combustion of C2H4. Enthalpy of combustion of C2H4. Okay. Reacting with O2 to form carbon dioxide and water. Okay. 2 carbons and 4 hydrogens. So 2 plus 2, 4 into 4, 4 into 2, 6. So this should be 3. All right. Okay. Now this enthalpy value delta H3 is given as minus 337.2 kilocalories per mole. Okay, done. So all that you have to look into is we require, this is C2H2, right? So we require C2H2 in the reactant side, right? We require C2H2 in the reactant side. Where is C2H2? C2H2 is here. Okay, we require C2H2 in the reactant side, and C2H2 is indeed in the reactant side. So we can keep second, this is the second equation, this is first equation, this is third equation. Okay, so we can keep the second equation as such. So we can just write delta H2 directly, nothing changes, right? Next, we require H2 in the reactant side. Where is H2? H2 is indeed in the reactant side, and it is in the first equation, and we are not going to do anything for this reaction also, because one H2 is required. Yeah, only one H2, right? Yeah, one H2 is required, and one H2 is there in the reactant side as well. So 2 plus 1, again I have to add what? We just have to add your delta H1 value directly. Okay, next what we need? We require, this is C2H4. We require C2H4 in the product side. Where is C2H4? C2H4 is here. So obviously we have to reverse this reaction, because I want, this is the reactant side, but what I need is in the product side, right? So we require it in the product side. Directly you take it. So if you write it in the product side, we have to take minus, that is reversing means minus. So minus 3. So we have to take minus delta H3. That's it. This is what is your delta H of the further reaction. Now, that's it. How much time it took for me? 20 seconds, 30 seconds? Very simple. Do not worry about any other thing. O2, H2O, CO2. Don't worry about anything else. See what is there in the required equation. See where do we have them and see how much we need them. That's it. That is all that is required. Do not worry about any other things. Right? It will eventually get cancelled out. That is how the questions will be framed. Don't worry about it. Yeah, tell me.
Sir, but in the required equation, we need the heat of formation of H2, right?
We need the heat of formation of H2. 0, right? H2O formation.
Okay, okay, sir.
Yeah. Right. Actually, yeah, we can, if they have given heat of combustion of H2, right? You could have done this actually, because again, you will be able to relate the enthalpy of reaction with respect to total enthalpy of combustion of reactants minus total enthalpy of combustion of products. So enthalpy of combustion of this and this are given. So if they have given enthalpy of combustion, then you could have done this problem easily. Okay, anyways, so this is the only way we'll be able to do this now. Very simple. Right. And weirdly, I can tell this point, right? Enthalpy of formation of H2O is nothing but enthalpy of combustion of H2. Can I tell this point? Write the equations for both of them. You will eventually see what is enthalpy of combustion of H2. That means H2 has to combine with oxygen to form H2O. Right? So you have to make sure that only 1 mole of H2 should be there undergoing combustion. So this is exactly what you will write for your enthalpy of formation of H2. Right? So a lot of weird connections you'll be able to get. Okay. Anyways, I hope everybody understood this problem. Very, very simple. Very, very simple. Yeah, tell me.
Sir, but then how do we calculate the enthalpy of formation of C2H2?
Enthalpy of formation of C2H2. Yeah, why do you need that? See, if at all you like, see, there is, how do we write enthalpy of reaction? Total enthalpy of combustion of reactants minus total enthalpy of combustion of products. That's it, right? Enthalpy of combustion of C2H2 is given, enthalpy of combustion of C2H4 is given, and indirectly this is nothing but enthalpy of combustion of H2 also. So you can directly substitute the values and get the answer.
Okay, sir. Okay, sir. Got it.
Okay. Right. Fine. Next question coming to you. So let me take another book itself. Just give me one moment, people. Okay. Let me search for a question. Okay, back to the question. So they have given enthalpy of formation of C2H6 is minus 85 kilojoules per mole, and this is given to you. And enthalpy of sublimation, enthalpy of sublimation of carbon graphite is given as enthalpy of sublimation of carbon graphite is given as how much? Plus 717 kilojoules per mole. And then what they have given, and enthalpy of atomization of H2 hydrogen is given as 218 kilojoules per mole. And the bond dissociation enthalpy, the bond dissociation enthalpy of CH bond is also given to you as 415 kilojoules per mole. Then what they're asking is, this is obviously in ethane, okay? This is in ethane. Bond dissociation of CH bond in ethane, okay? And then you have to find the bond dissociation enthalpy of CC bond is what? In ethane. Okay, right? So try this out. Anyways, I'm going to help you. Right? So look at what now is given to you, what you have to find, and think about it. And I'll be back in a minute. Okay. You read the values. Okay, these are the values given to you. Okay. This is actually a tricky question. Interesting. See the people. The clue is it has to do with the enthalpy of atomization or bond enthalpy of C2H6. Okay, start thinking from there. Start thinking from enthalpy of atomization or say bond enthalpy of C2H6. You know how to connect your bond enthalpies with bond diffusion enthalpies, right?
Sir, but then how do we calculate the bond dissociation enthalpy of C2H6?
Bond diffusion enthalpy of
C2H6.
we cannot calculate bond dissociation enthalpy. Bond dissociation enthalpy is only for a single bond in that particular molecule. We will be able to calculate the bond enthalpy. Like, I mean, not exactly calculate, right? But it has to do something with your bond enthalpy. Bond enthalpy or enthalpy of atomization of C2H6. I'll give you 2 more minutes time to think about it. And even if you're not able to solve, I don't blame you. This is a very good question. One more minute I'll give you. Not to get the answer, but at least to think about how are you going to approach this. Okay, fine. So let me do this. Okay. So I told you it has to do something with your enthalpy of atomization of C2H6, right? So when I want to write bond enthalpy of C2H6, how do we write this? C2H6, right? C2H6 should be going into the atomic state. That is 2 carbon atoms in gaseous phase plus 6 hydrogen atoms in gaseous phase. Right? And we know the structure of CH3, that is mean C2H6, CH3 is the structure. And I will be able to write the bond enthalpy of C2H6 as in terms of bond dissociation enthalpies, right? So I have one CC bond, right? So 1 into bond dissociation enthalpy of CC bond, right? Plus 6 into bond dissociation enthalpy of CH bond, because I have 6 CH bonds there. Okay, so this value is given to us, right? No, this value is given to us. Bond enthalpy, this value, bond enthalpy of CH bond, bond dissociation enthalpy of CH bond is given to us. But these two values we don't know. But somehow, if I can find this particular value, somehow, if I can find this particular value, this value is known, this value is known, eventually you will be able to find this answer. That is what is asked in the question, right? Okay, so somehow, if I can find this particular reaction's enthalpy, if I'm able to find, right, then I will be definitely able to go for finding the bond enthalpy of C2H6, and by that I'll be able to find what is the bond dissociation enthalpy of CC. Okay, now, okay, this is the required equation we need. Okay, this is your required equation, right? So let us look into what is given to us. Enthalpy of sublimation of carbon graphite is given to us, right? So how do you write the equation? Carbon graphite, that is obviously we know in solid state, right, is going to go to carbon gaseous phase. Is it not? Carbon gaseous phase. And that value delta H1, let us write it as plus, or it is only 717 kilojoules per mole. Okay, next is what is given. Enthalpy of atomization of H2 gas is given. So obviously it is going to go to 2H, because that's how we define it. Whatever be the molecule, convert into atoms. And for that, the delta H2, let us call it. So that is going to be 218 kilojoules per mole. Okay, these two are only given to, okay, we have enthalpy of formation of C2H6 also. So enthalpy, this is for this one, right? And enthalpy of formation of C2H6. Enthalpy of formation of C2H6, what we need? Carbon in the form of graphite plus 3 H2s is going to form C2H6. This is your enthalpy of formation. This is nothing but enthalpy of formation of C2H6. This is how we write this, right? And let us call this particular reaction as delta H3, and that value is how much? Minus 85. Right? Now what are we going to do? Exactly similar thing what we're going to do now. This is your required equation. That is the bond enthalpy of C2H6 is your required equation. And these three are your given equations, right? So something I'm going to do to this equation so that we'll be able to get that equation. Let me call this as 1, 2, and 3, right? Okay. So what we need? We require C2H6 on the reactant side. Where is C2H6? C2H6 is here, but it is there on the product side. So obviously we have to reverse it. Is it not? Right? So we require C2H6 on the reactant side, but in the product side, we have C2H6 in the given equation. So we will reverse it. So we have to write minus 3. That means we have to take minus delta H3. Whatever is the value, minus of that you have to take. Okay. Next, what we need? We require 2 carbon atoms in gaseous phase on the product side. Okay. So where is carbon atom? This is what is carbon atom in gaseous phase. Is it not? But I require 2 moles of this in the equation. It is there in the product side, okay, but I require 2 moles of this. So I have to multiply this entire equation by 2, right? Okay. So what do we need to do now? So we should write 2 into equation number 1. So that means I have to add 2 into delta H1, right? Okay. Now what is required? Next, I require how much? I need to have 6 hydrogen atoms in the product side. Where is hydrogen atoms? Hydrogen atoms are here, right? Hydrogen atoms are here, and I require in the product side. Yes, it is there in the product side, but I require 6 of them, but only 2 of them are here. So obviously this has to be multiplied by 3, so that I'll be able to get 6H, right? So what are we doing? We are adding obviously this one, so that we are doing how many? 3. We are multiplying through the equation number 3. So obviously we have to add 3 into delta H3, and that's it. We are going to end up with your bond enthalpy of C2H6, because that is your equation which you got, right? So now this equation, this particular value, whatever you have, will be substituted here. Bond enthalpy of C2H6 we know now. This value is already given to us, this value will be most efficiently found. Very, 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 very simple. Okay, it looks a little complex, right? But it is not. Again, I repeat, whatever I have done, I started with bond enthalpy of C2H6. So we require 2C and 6H, right? And we can write the bond enthalpy in terms of bond dissociation enthalpy. So that is 1 into bond dissociation enthalpy of CC bond plus 6 into bond dissociation enthalpy of CH bond, right? And they have given some enthalpy values. I wrote the equations for that. Okay, now I'm trying to find what this I'm going to consider this particular equation as my required equation, and these are the given equations, and we have done so many problems based on that, reversing it, multiplying it, something. We eventually got the required equation, and we eventually got the bond enthalpy. And bond enthalpy, you know, the bond dissociation enthalpy of CH bond is already given in the question, so you will be able to find what is the bond dissociation enthalpy of CC bond. Okay, right? I hope everybody understood, right? Do you want me to repeat again? Anybody has any problems here? Good question, right? Very good question, right? Okay, people. So I hope everybody is doing good, right? So let us stop with this for today, right? Next class we'll do little more number of problems and little more types of enthalpies are there. All those things we will see, and maybe next class will also go into enthalpies only. Okay, and like some new enthalpies and their problems, and the whole problems will continue. So next class will be a 2 hours class, because next Saturday, Sunday I will be available. So next class will be 2 hours class, and we're able to do more in that. Okay. So if there are no more questions, I think we can wind up. Any questions anybody particularly has?
Sir.
Yes, tell me.
Sir, actually, we have an exam coming up. Could you revise the S block and P block elements, if possible?
Next class?
Yes, sir.
Okay. S and P block. Huh? Fine, we can do that, but the continuation will be missing. Fine, okay. We'll do that. Like, how many of you have exams like that, people?
So all DAV school students.
All DAV students, sir.
All DAV students have exams. Okay. Fine, let me see what I can do. Okay. Right, but the thing is, I can do that, but the thing is, if I miss this again, the continuation will be missing. When I come back to thermodynamics, nothing you'll remember, basically. Nothing you'll remember. That's the only problem I will face. I mean, that you will face. So fine. Anyways, whatever you need, we'll do that. We'll see what we can do. Okay. I'll keep this in mind.
Chemistry
Fine,
exam
okay.
is on 16th, sir.
Yeah, exam is on 16th.
Yeah,
Okay.
chemistry.
Okay, fine. Don't you have thermodynamics for that?
Yes, sir. We
have,
also have thermodynamics.
Then that also has to be completed, right? So rather than like say starting with new something and say not completing that, not completing this, we can at least complete one thing properly. That is what I suggest, right? Whatever you feel. Anyways, we'll discuss in the next class. Okay, we'll see you. Right? Thank you so much, people. We'll meet again.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, everybody.